In this lesson, we're going to go over function transformations, which is a topic that describes how the graphs of functions are shifted around the Cartesian plane. That is, shifted left, right, up, and down. So let's recall this. If we're given a function, y equals f of x, and some positive number c, then we have these 6 methods that describe how the graph of that function will be shifted around the Cartesian plane. So if we take the function f of x and we replace the x with an x minus c, then the graph of y equals f of x minus c will be the same graph as the one we started with, y equals f of x. However, it will be shifted to the right by c units. If we take the same function and we replace x with x plus c, then that will shift the graph of y equals f of x to the left by c units. And if we take the original function, y equals f of x, and we subtract c on the outside, so notice the c is not in the parentheses with the x. So if we just take the original function and subtract c from it, then that will take the graph of our original function and shift it down along the y-axis by c units. If we take the function and add c to it, notice this c is not in the parentheses, then that will take the graph of our original function and shift the graph up c units along the y-axis. And then if we take the x up here in our original function and replace it with negative x, that will actually flip the graph of y equals f of x about the y-axis. And if we take the original function and make it negative, then that will flip the graph about the x-axis. Now for these two, these might be a little difficult to see. For this one right here, y equals f of negative x, think of it like this. If you have the graph of a function, so here we have the graph of just some arbitrary function. If you replace the x in the original function with a negative x, that will make all the numbers on the positive x-axis, it will make them all negative. And it will make all the negative numbers on the x-axis positive. So all the positive become negative, negative become positive on the x-axis, and that's equivalent to flipping the graph about the y-axis, like this. On the other hand, if you just multiply your function by a negative 1, then all the numbers on the y-axis will get flipped. So all of the positive numbers on the y-axis become negative, and all the negative numbers on the y-axis become positive. So that's equivalent to flipping your graph about the x-axis. So that's why you have this behavior outlined in numbers 5 and 6. Now let's take a look at this example. So here we have the graph of the function f of x equals x squared down here. This is our standard parabola. And let's consider the transformations f of x minus a plus b. So in other words, that would be like considering these transformations like this. Now notice, here's our function right here with our a and b. Now if I move the slider bars, you'll see the a and the b will change, and keep an eye on what happens to the function as we do that. So notice right now our a is 1 right here, and so we're graphing f of x minus 1, and notice that our graph shifted, its vertex was here, it shifted over here to the right by 1 unit. On the other hand, if we do this, so now we actually are considering the graph of f of x plus 1. So now this a actually would be negative 1. Remember, minus negative 1 gives you a positive 1 here. Okay, so now this is actually shifted to the left by 1 unit. Now here's the way I think of this shift left and right. This might help you to remember which one is which. If we start with the original graph, y equals x squared, and we consider a shift like this. Alright, so you might think, okay, does this shift it left or right? I forget, does minus 2 shift it right, or does it shift it left? Which way does it shift it? Well, think of it like this. In the original graph, if x is equal to 0, then y is equal to 0. Now down here, if you want the y to equal 0, well, we need to let x equal 2. So if x is 2, y is 0. So the point 0, 0, which was when our graph was right here, so right here was the vertex 0, 0, that actually got moved over to here, where x is now 2. So replacing the x with an x minus 2 shifted it to the right by 2 units. And you can see that from the graph here. Right there is f of x minus 2, and notice our vertex got shifted to the right by 2 units. On the other hand, if you consider y equals x plus 2 squared, well, in order for y to be 0, what should x equal? Well, if we set x plus 2 equal to 0, we get that x must be negative 2. So the point 0, 0 gets moved to negative 2, 0. So the point right here gets moved over here. So we get a shift to the left by 2 units. And you can see that if I move the slider bar, so right here. So right there is x plus 2 squared. And this is the graph of x plus 2 squared. Y equals x plus 2 squared right there. Now on the other hand, if you consider this function, now the b, that's simply going to be shifting our graph up and down by b units. If b is positive, it will shift it up. If b is negative, it will shift our graph down, because it's really changing all of these y values. It's really like adding b to all of our y values on the graph. So if you add b units and b is positive, it'll shift it up. If b is negative, the graph will be shifted down. And we can see that if we keep an eye on this value right here, that's our b. Let's see what happens when that becomes positive and when it becomes negative. So now you see the b is right now about 3.95. Notice how the graph got shifted up by 3.95 units. And if b becomes negative, like right here, it's about negative 4.9. Notice how the graph got shifted down. So that vertex right there, its y coordinate would be about negative 4.9. So that's how you can think of these transformations. Now let's take a look at an example. So beginning with the graph of y equals the square root of x, let's sketch the graph of y equals negative the square root of x plus 3 minus 5. So let's put the Cartesian plane down here, and we'll try to figure out what that graph looks like. So here we have our Cartesian plane. Now you do have to remember what the basic graph of the square root of x looks like. That will look something like this. You can graph this on a calculator. Check this out. That's the basic graph of y equals root x. Check that out on any graphing calculator. Notice our domain is 0 to infinity and our range is 0 to infinity. Now let's see, what would happen if we replace the x with an x plus 3? Well, what's that what that is going to do is shift our graph to the left by 3 units. So this point right here, 0, 0, gets moved over to -3, 0. And so here is the graph then. That's roughly what the graph of y equals the square root of x plus 3 would look like. Now let's take into account the negative right here. What will that do to the graph? Well, that will flip it about the x-axis. So that will give us this graph. Something that looks like that. So that now is our graph of y equals negative the square root of x plus 3. And now let's take into account the -5. What's that going to do? Well, that's going to shift the entire graph down by 5 units. So this point will then be moved down to here. Let's say that's -5 right there on the y-axis. So it would be moved down here. And here would be our final graph. It would look something like this. And that would be our final graph of y equals negative the square root of x plus 3 minus 5. And so you can see how we started with our basic graph of y equals the square root of x. We shifted it to the left 3 units by replacing the x with x plus 3. Then the negative out front flips the graph about the x-axis, because remember, putting a negative in front here is like replacing f of x with negative f of x. So that's a flip about the x-axis, because all the positive y's become negative, all the negative y's become positive. So we get the green graph down here. And then we just subtracted 5 from the green graph, and that shifted it down by 5 units, and we got our final graph right here. So that's how these shifts work. Left, right, up, down, reflections about the x and y axes. Let's take a look at another example. So here we want to start with the graph of our basic parabola, y equals x squared, and then try to sketch the graph of this function, x squared plus 6x minus 11. Now what we want to do is we want to take this function and we would like to rewrite it like this. We would like to rewrite it as if we can rewrite it like this, then we can easily read off that we take this graph and shift it left or right a units, depending whether a is positive or negative, and then up or down by the absolute value of b units. So we have to do what's called completing the square on this first. Now remember how to do that. So if I start with a quadratic that looks like this, x squared plus bx plus c, we're going to do a little math trick here. We're going to take this and we're going to add in b over 2 squared and subtract it right back out. So you see here it's added in and subtracted right back out. We take whatever that b is, divide by 2, square it, take that number added in, subtract it right back out. So this term right here, these two terms are actually 0, and so we haven't changed anything. Now the reason we do this is as follows. Notice that what we can do now is take this piece right here, and notice that this piece, if we can factor it as this. And so that's right here. Notice if I FOIL this out, you have to remember how to FOIL, I get x times b over 2. Or first of all, let me start that over again. If we want to FOIL this out, it's x times x, so that's x squared, x times b over 2 plus b over 2 times x, so that gives me b times x. b over 2 plus b over 2 is just b. And then b over 2 times b over 2 is b over 2 squared. So you see this term right here is just x plus b over 2, the whole thing squared. And then this term right here, this is going to be just added on to this. We'll call that some number, whatever, capital C or whatever. And so what we have is we can take this, rewrite it like this, and then we see that we have a shift left or right by b over 2 units and a shift up or down c units, depending on the signs of b over 2 and the capital C right there. That's called completing the square. Now let's do that to this function that we have up here. So if we start with now notice that our b term here is 6, so right there is b. So we will write this as, now 6 divided by 2 squared, 6 over 2 is 3, so 6 over 2 squared is going to be 9. That's 3 squared. Minus 9 minus 11. Now, notice that x squared plus 6x plus 9, well, that factors nicely as x plus 3 squared. And then we have over here minus 20. And there we go. Now, we've written this function in a form where we know how to shift the graph left or right and up and down. So now what does the graph of this function look like? Well, if we start with our basic graph of x squared, so I paused the video and quickly sketched in the graph of y equals x squared over here. So right there's our base graph, y equals x squared. We see that the graph of this function, we're going to have a shift to the left by 3 units. That's what this represents. So it's going to shift this graph over to here, so the vertex gets shifted over here. And then the minus 20 will shift the graph down by 20 units. So the vertex will go from here to here, and then down to here. I have that marked as negative 20 on the y-axis, so the x and y-axes are not quite to scale. They're not using the same scale. And then our graph would just look like this. Something like this. And you can sketch that on your calculator to check that out. So that is the graph of, and the way we obtained that was by completing the square to rewrite it into a form like this, where we could easily read off a left or right and an up or down shift.